fundamentally we're having like three items to actually as a form of checker. So we have first the column, we have the positive diagonal, we have the negative diagonal that's like put into a set. So when you talk about having a set, that means there's like no duplicate at all. That's why they are very suitable to be a form of like a checker in my opinion. So what it really comes down to is that we have a form of like a decision tree, and that I mean like within this row we can have to put at the position of like position 0, 1, 2 and 3, right? Which is the queen can be here, it can be here, it can be here, and it also can be here, right? So it just plays out all the different every single possibilities. So now and given like the first position, like the queen can be placed, the next queen can be placed over here, you can place over here, place over here, you can place over here, right? So therefore whatever you see over here is that under the next row it's gonna place under 0, can 1, the 2s and the 3. So now because each of the item, when you kind of like brute force, is going to go through every single checker. So it's like you having this singular item that's going through like this 3 different boundary, and boundary number 1 is to check for maybe say your column. The boundary number 2, it's going to go through your positive diagonal, and the third one, it's your negative diagonal. So when you place onto the first one, which is over here, it's gonna go through like the column set, and it's gonna say that yo, this guy is like within my same set. And when it's like under the same column, it's gonna like reject this item. So therefore it come here, it's gonna reject. And now it's gonna place onto like the queen onto this item. But then your negative diagonal is gonna say that you are in my this set, you can't have share the same set as me, you know. And so I cancel this thing out. But when you place over here, it's suddenly fine, so you kind of like stay per normal. You place over here, it's kind of like fine, so you stay per normal. And as you can see, each time like a brute force item, it has to go through these 3 checkers to make sure that okay, you are within like boundary, and that you're following the rules of like the n queens. So yep, everything that's everything that they've discussed. And if you were to actually go through every single item, you notice that you can't go through every single item. Like amongst the n square, you are going through all this 3 checkers, you are going to have like lesser value than maybe say this whole of n square, because not every item is going to be available, and in fact it's going to cut down by a lot of the items. Whatever we've been doing over here, it has been having like this form of like checker. So the moment you need like some form of like checker, you can think of like maybe say a set. And yeah, in some cases you can even think of having some kind of like hash map, right? And for this case, a set just does the job. And to be honest, this guy is kind of like under the category of like a side character, I'll say. And notice how we are going through a lot of like different patterns. It's like there's like a total of like maybe say 4 pattern, and how many 4 pattern can I multiply into. That's how I actually view this whole thing. And it's like it's counting based on the max number of groups that there is. When you say maximum number of groups, I straight away will think of like backtracking. I will think of say this brute force way of like doing things, which is what fundamentally they are doing over here. It has like this backtracking brute forcey way of going through every singular item to find the max groups of things. And under the max groups, they have to go through all these checkers to cut down like the 4 power of n into something very very small, because there's a lot of rules and you're gonna like make it as conducive as possible. And one way to actually talk about like the columns is very straightforward. If your column is 0, I'm gonna check you out. If your column falls under 1, I'm gonna check you out. A positive diagonal is something not so straightforward, but as you can see, when you go positive diagonal, what you're gonna realize are the values for say like a positive diagonal. This value is maybe say 3, 3. If you say you do a row plus column, it has like this constant value, which is 3 plus 0, 3, 2 plus 1, 3. And if you realize, it's always like the same value. And so you can use that to actually abuse, to actually check that each time you plant an item, maybe say I plant an item over here, I check what row and column it is, and if I plus it, if it equals to this constant, that means you are falling under like the same positive diagonal. So whatever you have to actually truly check is like the row plus column for say positive diagonal. And you have the positive diagonal, you also have like the negative diagonal. Negative diagonal is that you notice that this thing is like 2, 2, 1, 1. And so if you row minus column is row equals to this constant, notice 1 minus 1, 0, 0, 0, 0, 3 minus 3 equals 0. You notice that the R minus C, the row minus the column, is equals to this like constant value. So each time maybe you say you plant this item to be over here, you get this constant. Then you later on you try to plant a value over here as like the constant. So if an item it already been pre-planted into the set, the next time you plant an element over here, it's gonna say that yo, this guy has like the same value as me. I can't allow that. So if you were to plant this second item onwards, well, after you plant this first, this second item is gonna be rejected, because in the set you only can have like one item. And so negative cycle negative diagonal, you're going to use the formula of R minus C to actually check for this second duplicate item to get cancelled out of. And under the rulebook, it's really to do with saying duplicate within like the chess rule. And to actually break it down, like the chess rule is actually these three rules basically. First, we have like say the column. Second, it has like this positive diagonal. It has this negative diagonal. Last but not least, if you were to see, like each pieces, they can't be placed on like the same row, right? So it's like you're finding the combination, like after you place a 0, you can't place a 0 again. So in some cases, when you are going through like the pattern, you're also making sure that the row is like different. You're taking like a different combination of like the, say like the max group that get placed on these different places. And when you're like checking for like following the chess rule, whatever you're actually saying is that I can't have like duplicate within like these 4 places, therefore you include the set. And you want to find like the max number of it, therefore you backtracking to actually get the max group number of like groups that you can actually produce. Here obviously we've been talking a lot about the spells that we've managed to cast out. Here it's very much to do with the rulebook that we've managed to actually produce so far. We can also use this brute force to actually fight against our main character, but for the most part, backtracking, it follows the rules of like brute force. So that's how I actually gonna, invite brute force to actually fight with us. When I think about this brute force, I think of it as like some form of like omega brute force. It's like omega brute force. And why I actually say that is because like it's just trying to literally go every single path possible. You have the 0, every single set of 0. You have 1, you constantly can always like multiply yourself by the 4. And to me, when you can actually do this item, it's like an omega brute force. But I don't know, maybe in some cases they don't actually allow that. Maybe say like, because I do know that so for some of the backtracking categories, there's this combination where you follow the fundamentals of like echo forward. That means whatever you use from previous, you're not gonna be able to actually carry forward. But for this item, it just feels that you just literally just you can put in everything that you want. So for combinations, one of like the example is that say that okay, I have like the 2, so that has like a duplicate. So once I come to here, maybe say that I mean the moment that you actually branch out over here, here is a 0, here's a 2, and here's a 3, and this guy can't be actually included because you can only create like items with 2 and no a 2. Alright, so as you can see, whatever combination is doing is actually cancelling out your branches. But for this guy, whatever it is trying to do is that it's very free to actually do whatever we want. So that's why I say that combination, it does limit you in some cases, in most cases at least. So yep, with that everything comes to an end.